This is John Black, super chemist, here to make some calcium sulfate and some ammonium chloride. But before we get into that, I want to talk a little bit, because this is an important reaction, at least to me. It seems like an important reaction. Because here's our equation, how we're going to make it. Alright, we got some ammonium sulfate, and we just made some calcium chloride hexahydrate in the last video. And that's the whole reason we made it, was just so we can do this reaction and talk about this reaction. Okay, now when you add these two together, this will be soluble in water, that will be soluble in water. Now you'll mix them two aqueous things together, and you will get calcium salt. You'll get all these ions: calcium chloride, ammonium ions, sulfate ions. Calcium sulfate is not very soluble, so it's going to precip out. Ammonium chloride, that's soluble, so those ions are going to stay in solution. You can let it dry, just put it in a flat pan and let it evaporate naturally, and the crystals that come out, leave a little bit of water in there so that, it soaks up the impurities, and filter these crystals out and wash them a little bit with water, and you got pure ammonium chloride. Now look at the solubilities of calcium sulfate. That's another weird thing about this, why I wanted to bring up calcium sulfate, is it has like a retro solubility or whatever. It's weird, because the hotter things get, the more soluble it should get. And it does up until 20 degrees. Then look, 80 degrees it's going down. 100 degrees it's going down even more in solubility. So it's got a freaky whatever, but you can see the difference between all of them is like 0.02 grams per 100 milliliter. So you can only have some, a little bit in there at 100 C, but at 0 C it's barely any different. You know what I mean? If you want to recrystallize your ammonium chloride out, you're not going to have anything come out really of the calcium sulfate. It's going to stay in solution as long as you leave a few milliliters in there, to absorb that up. But what I wanted you to see about this equation, or this type of reaction, is this. This is not just how you make ammonium chloride. This isn't how you make calcium sulfate. It's how you make any salt, almost. Now, I just picked these things out of my head. I didn't look them up, so I'm not saying every one of these will work. There's always an exception to the rule, and one of these might be those exceptions to the rule. But these are just some examples. Let's say I used iron 2-sulfate and calcium nitrate, right? Now, remember, this calcium sulfate is going to precip out. What are you left with in solution? Iron nitrate. And then you can filter out the calcium sulfate and let it dry naturally, the water evaporate, so that it forms the crystals nice, and then filter it out. Same here. And then, these are my examples for here, these are my examples for here. Basically, I'm saying whatever salt you want, you would have the cation coming from the sulfate, and you would have your anion coming from your calcium salt. Now, like I said, I don't know if these will work. They're just examples that popped out of my head. I didn't really look them up or anything like that. But because that's not what I'm trying to get. That's not my point. My point is that some salts are, a lot of salts can be made because this calcium sulfate is pretty much insoluble in water. And the part that is soluble, the little bit that is soluble, there's not much of a difference between 100 degrees Celsius and 0 degrees Celsius. So when you recrystallize out the other salt, this won't come with it, really. See what I'm saying? Isn't that nice? You don't have to use any bases. You don't have to use any acids. But the thing is, you need the calcium salt and you need the sulfate salt to do this. That's why I had to make calcium chloride, just so I could get the chloride. I already have ammonium sulfate, just so I could get the chloride part of this. Now I want you to check this out, okay? What if you used instead of calcium sulfate, you wanted the calcium carbonate to precip out, okay? This is the same exact thing up here. See, you got your ammonium, chloride. You got your calcium and something that's going to help precip it out. In this case, it's calcium carbonate. On the first example, it was calcium sulfate. And calcium sulfate's good, but look at ammonium carbonate and calcium chloride. You're going to precip calcium carbonate out, right? A calcium carbonate is even less soluble than this. You think 0.205 is not that much? Or what about 0.0013? 0.001.2. That's a big difference. This is like nothing. This is counting molecules now, okay? 0.013 per liter of water. Even in a liter of water, you ain't even close to this 100 milliliters up here of the calcium sulfate. This is like nothing. This is a joke. So if you did it this way, you could literally almost evaporate all the water off and just take all the crystals. You wouldn't even have to worry about contamination almost. I mean, this is nothing. This is literally nothing. So it's not just the calcium sulfate thing. Any salt that is insoluble, right? You can get two salts and just have, you know what I mean, take part of the one salt and have it be on here and take part of the other salt. That way when all four ions are in solution, right, these are soluble, but when you put them together, now you have ions of calcium and you have ions of carbonate. They will precip out and leave you with your product that you want. See how nice that is? These are just two examples, but there are many examples that you could do like this to make your salts. Alright, I got ammonium sulfate ions in here. I got calcium and chloride ions in here, right? All soluble. But when I pour these sulfate ions into the calcium ions, they're going to touch each other, and when they do, they're not soluble. Let's get maybe a little closer. Look. See there? So there's my calcium sulfate, you can see. So I'm just going to filter this out. Just going to get as much water as I can out of there. Switch to a bigger filter. Alright, so I put some more water in the beaker I was using and stir it around to kind of clean it up, get some of that out of there. And I'm going to wash this. I'm going to pour it right in here. The solubility between warm and cold for the calcium sulfate is not very, there's not much difference, so it doesn't matter. But if you use warm, the other stuff will be more soluble, the stuff you want to get out of there, you know what I'm saying? So it's better just to use like really warm water. Okay, so I'm going to suck all this water out, right? And then I'm going to add, you see I got some more in here. See there? Clean some more of that out. Total, probably I'm going to use about 500 milliliters, 400 milliliters. you know, and put 100 milliliters in at a time. Stir it around, you know what I mean? And then put a vacuum on it and let it all get, it's not going to be dry, but let it get most of the water out. It'll still be kind of like pudding. And I'll just repeat that until the water's gone, and that should make it clean enough. And you can see I got some salt making it through the filter. So I'll filter this again. So there's a calcium sulfate I made. This is the stuff that got filtered through. I filtered it again because it had little particles in it. Now it's nice and clear. And I'm just going to boil this away. Now what's left, if we took all the calcium ions out and we took all the sulfate ions out, the only thing left in there is ammonium ions and chloride ions. So the only thing that should be in solution right now is ammonium chloride. Keep in mind there might be a fifth of a gram of calcium sulfate in there too. Maybe even a half a gram. So we're not going to let all the water evaporate, but we're going to evaporate some of this water down. It's boiling, and I got some crystals coming out of solution. I'm just going to let it cool down naturally the rest of the way. I don't smell any ammonia. I thought you'd smell ammonia, but I don't. That's the nice thing about this reaction is there's no fumes, no acids, no bases. I mean, you should still always wear gloves and goggles. But you really don't even need a fume hood or anything. I mean, there's nothing nasty about it in that respect. So it's cooled down, so I'm going to pour it into here. And we'll let it crystallize from there. I got to change plans. I think this is calcium sulfate that's coming out. Look how much water that is. That's like 300 milliliters. Now, I've only made about 27 grams of ammonium chloride. I mean, I only need like maybe 35, 40 milliliters of water for it to dissolve. But there's no way anything can be coming out of solution yet. So I'm going to pour this in here and filter that out. So not only is that a lot of water for a lousy 27 grams of ammonium chloride, I took a little bit of sample out of the stuff that precipitated. I don't know if you can see it on camera. If you can see it down at the bottom in the corner, it's just a little dab I took out. But anyways, it's still there. Now, if this was ammonium chloride, it would be dissolved. You know what I mean? You can see it now, I think. But anyways, it's still in there, so there you go. You can see when I turn the thing. So it has to be calcium sulfate. Another thing is that I put this in the freezer, this pan that I had it in, right? And if it was ammonium chloride, a lot would have precipitated out. And really there was no change in the precip. It was the same amount. And that's what would happen if it was calcium sulfate. Alright, so here's my new plan, right? I'm making 27 grams of ammonium chloride. 36.4 milliliters of water is needed. You know, you can get 27 grams into that. That's the minimum water you need. So I jacked it up to 50 milliliters. Make sure I, have it in there. Now I'm guessing when you add 27 grams of the ammonium chloride to the 50 milliliters of water, the ions probably take up less room than the actual salt. But I'm just going to say that it's 1-for-1, okay? I don't care if there's slightly more water in there. So if I add them up, that's 77 milliliters